On this 2015 to 2025 F150 with the 2.7 EcoBoost, P0171 may point to a possible lean condition on one side of the engine. The driver may notice a rough idle, hesitation, lack of power, or the light may simply be on with no obvious complaint. Broadly, this kind of code can involve unmetered air, intake or vacuum leaks, fuel quality or delivery issues, exhaust concerns, sensor feedback, wiring connectors, or module input problems. For this episode, the diagnostic path available is a gateway-style method, not a P0171 specific pinpoint test, so stay disciplined. Prove the concern, work the basics first, and do not guess at bank-specific tests or repairs that are not supported here. Start with the basic system checks before chasing the code. Look for any obvious issue that matches the customer complaint. Check available vehicle history and any related bulletin information. Then look closely at previous repairs, because an incorrectly completed repair can create the exact problem you are diagnosing now. Before you go deeper, make sure the battery and charging system are operating correctly, and verify battery SOC is greater than 70% before beginning diagnostics. Next, scan all network modules for system or symptom codes that relate to the concern. If other codes are present, use them to decide where to start. Circuit-related codes get handled before system or performance-type codes. If you have multiple circuit faults, look for a shared cause, like a common spliced power or ground circuit, instead of treating every code like a separate failure. Now, do the hands-on inspection in order. Check the wiring harnesses for damage, chafing, and routing. Check fuses, circuits, and connectors for continuity and correct installation. And make sure all components are properly connected. Then move through the areas that matter for a lean-style complaint. Inspect vacuum lines, the air intake system, and hoses for leaks, damage, blockage, routing problems, or restrictions. Check fuel quality, including octane, contamination, and seasonal blend. Inspect the fuel tank and fuel lines for damage, leaks, and routing. Also check coolant level and quality, oil level and quality, and inspect the exhaust system for damage, restrictions, and routing. When you connect test equipment or jumper wires to pins, use Rotunda Flex probes, MUD 105R025F, or Terminal Probe Kit 418S035, so you do not damage the terminals. Check male to female terminal fit with the mating pin and feel for normal separation force. A damaged pin will have very low separation force. If the connector hardshell adds drag and prevents a good check on small terminals, remove the pin from the hardshell as needed. If you find damaged connectors, pins, or terminals, replace the damaged pieces. Use the scan tool to read PID inputs, output states, and diagnostic states. Monitor PID information in the data logger so you can test accurately without unnecessary disassembly. Where the tool allows it, command module outputs with PID control. For module-related checks, make sure you understand normal module function, and make sure programmable parameters are set correctly for the function in question. If a DTC points you to a specific diagnostic path, resolve that DTC first before moving on. Then test all hardwired and networked inputs, test outputs, and check for module software updates. Normal output function points you back toward analyzing the module inputs. Do not condemn a module from weak testing, and do not apply ground or power directly to module switched components unless the diagnostic path specifically tells you to. If the diagnostic path moves into electrical testing, do not rely on unloaded voltage checks to find excessive resistance. With the intended load disconnected, a voltage check may only show a fully open circuit. For circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure voltage with a digital multimeter while the light is connected. A voltage reduction during that loaded test points to excessive resistance. A 250 to 350 milliamp test light is also used for conductor sizes 24 gauge, that's about 0.5 millimeters or smaller, that generally carry around 1000 milliamp, which is 1 ampere or less. On the larger side, conductor sizes 20 gauge, about 0.8 millimeters or larger, are generally used to carry around 1 ampere or more. For circuits carrying more than 1 ampere, load the circuit with a similar current device, such as a brake light bulb. For higher current circuits, voltage drop testing is the better method. For ground-providing circuits, measure voltage drop while the component is operating or trying to operate. Use an ohm meter accurately, only with the battery disconnected, and disconnect the battery before using a DMM ohm meter on body and chassis ground circuits. Keep the meter's limits in mind. A standard DMM ohm meter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. For most small diameter wires, 18 gauge and smaller, expect less than 2 ohms. For most wiring harness circuits, also expect less than 2 ohms. Reverse the DMM leads and watch the reading. If the resistance changes and the circuit does not contain a semiconductor, treat the test result as invalid. To check for unintended continuity to ground, disconnect both ends of the circuit and measure between the suspect circuit and ground. Expect resistance greater than 10,000 ohms. To check unintended continuity to other unpowered circuits, disconnect both ends of both circuits and measure between them. Again, expect resistance greater than 10,000 ohms. For a short to a powered circuit, disconnect both ends, turn ignition or run power on, and check voltage from the suspect circuit to ground. Back probing is only for tests that must be done under actual operating conditions, such as a required voltage drop check, or when opening the circuit could change the failure behavior. In a voltage drop back probe test, expect some voltage, normally less than 5% of circuit operating voltage. A 0-volt result in that situation means the test conditions are wrong, there is no current flow, or the back probe connection is bad. Do not force test leads or probes into connectors, and use probes designed for back probing. Do not use back probing for a single-point presence of voltage test when 0 volts is a possible result, and do not use it for continuity or open circuit checks with an ohm meter. In those cases, disconnect and isolate the circuit, then test normally. When jumper wires are used for circuit analysis, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse. Use flex probes or equivalent tools to avoid terminal damage. But do not use flex probes to power cooling fans, blower motors, or other high current devices. They are not intended to carry high current greater than 5 amperes. Follow the diagnostic test directions carefully with jumper wires. And do not repair a failed circuit by simply adding a parallel wire without understanding why the circuit failed. Find the fault, examine it, repair the root cause, and repair any adjacent damaged wiring. For a voltage drop measurement, connect the voltmeter at the beginning and end of the suspect circuit and run the test with the circuit operating or attempting to operate. Connect the leads so polarity follows conventional current flow. A 0-volt reading means the voltmeter connections are bad or the component is not turned on. A small amount of voltage is normal circuit loss. In 12-volt circuits, this is usually less than 0.5 volts, and you should expect less than 5% of circuit operating voltage. Greater than 0.5 volts is abnormal voltage loss and points to high resistance in wiring or connectors. For a voltage in, voltage out test, put the negative voltmeter lead on ground or battery negative. Test while the circuit is operating or attempting to operate. Then measure the power side and the ground side of the load. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. A reading of 0 volts or source voltage indicates an open circuit. Keep verification separate from testing. After correcting a confirmed fault, verify the repair and confirm P0171 stays gone. Because this path does not provide a P0171 specific confirmation routine, do not invent monitor criteria or replacement decisions. The takeaway is simple. For P0171, prove the concern is present. Handle circuit faults first. Inspect the air, fuel, wiring, connector, fluid, and exhaust basics in order, and only then move into controlled scan tool and circuit testing. For more diagnostic training, visit stepdiagnostics.com.